In this video, we're going to learn how to create a 5-number summary. We're going to need some data to do that, so we have here a sample of 15 years of quarterly data showing the number of injuries in a manufacturing plant. I'll assume a very basic familiarity with Excel software, which is what we'll use for this video. It's clear that the number of injuries per quarter and per year is uncertain and subject to natural variability. The 5-number summary provides a concise summary of the distribution of the observations. We'd like to represent the uncertainty using the 5-number summary. Reporting 5 numbers avoids the need to decide on the most appropriate summary statistic. The 5 numbers comprising the 5-number summary are the median, which provides some information about the location of the distribution, the first and third quartiles, which describe the spread of the observations, and the minimum and maximum, which define the range of the observations. So let's see how to create this summary. We'll start with the minimum. And what we're going to do is we're going to use the Excel function library. We're going to go to More Functions, Statistical, and we're going to scroll on down and look for the minimum. Here it is here, MIN, and up opens this function argument box. All we have to do is highlight the array of numbers from which we would like the minimum selected and click OK. For the first quartile, we go to Statistics again, and this time we're looking for a percentile. We're going to use percentile inclusive, identify the array, and K is how we indicate the percentile we're interested in. We're interested in the 25th percentile, which is the first quartile, and this is given over the 0 to 1 array, so we enter it as a decimal, 0.25. Statistical functions, and this time we're looking for the median. Once again, we identify the array, click OK. The third quartile is much like the first, looking for the percentile. We get the array, choose the K value, which in this case is 0.75, and then finally the maximum. MAX, select the array, click OK. The minimum is the smallest value in your sample. It may or may not be the smallest value possible, depending on the nature of the variable. Here, 0 injuries is the logical absolute minimum, although it has never been observed in the sample. The first quartile, 25% of all the values are less than or equal to the first quartile value. Alternatively, 3/4 of all the observations exceed this number. So 25% of all quarters have 6 or fewer injuries. 75% of all quarters have 6 or more injuries. As we move to the median, this is the value that's in the middle of the observations. Half of all values are equal to 10.5 or less, and half are equal to 10.5 or more. So we're saying that 50% of all the quarters, there was less than 10.5 injuries per quarter. Likewise, in half of all quarters, there were 10.5 or more injuries per quarter. The third quartile, 75% of all values are less than or equal to the third quartile value. Alternatively, 1/4 of all values exceed this number. The maximum is the largest value in the sample, and it may or may not be the largest value possible, depending on the nature of the variable. And here there is no logical maximum number of injuries observed. So our 5-number summary gives us 5 ways to describe the observations. The median gives us the location of the data. The data tend to cluster around 10.5 injuries per quarter. Notice that 10.5 is not an observed number. The minimum and maximum bracket the experience and say that at plant A, they've never had less than 2 injuries and never had more than 21. The first and third quartiles give us some idea how the data are spread around that 10.5. Notice that there is a difference of about 4.5 between the median and the first quartile, and a difference of about 6.5 between the median and the third quartile. So there's a greater spread on the larger number of injuries. It's possible to quickly compare several sets of observations by comparing their 5-number summaries. So here we have plant A above, which we just completed, and plant B below, which is this second set of data here. Notice that the minimums and maximums are identical for both plants. Plant B has a higher injury profile. The key here with a 5-number summary is when there is uncertainty, if you use a point estimate to represent an uncertain value, it's going to be misleading at best, and it could be deceptive at worst. You could pick a distribution value. You could pick a mean, for example, but all values in the 5-number summary are order statistics. So the 5-number summary is appropriate for ordinal measurements as well as interval and ratio measurements. And that's part of its appeal. So this is a well-established and common way to represent uncertainty.